Hey there, Mr. Sutton here, bringing you the AB Calculus 3.8 Classwork Extra Practice Solutions on implicit differentiation. On this problem, we need the derivative of this equation. Since y is tough to isolate, we'll use implicit differentiation. Derivative of y cubed, that's going to be 3y squared times a tail of dy over dx using our chain rule. Next, derivative of y is going to be dy over dx, and that's going to equal the derivative of x squared, which is 2x. Now, all the dy or dx's are isolated on one side, so that kind of saves us the trouble on that next step. We just have to factor out a dy over dx to isolate it. So that'll leave us with 3y squared plus 1 inside of parentheses. And then dividing by 2x by all that, we've got 2x over 3y squared plus 1, which gives us answer choice E. On this problem, we're trying to take the derivative of this equation. Y is awfully tough to isolate in this one, so we're going to go ahead and use implicit differentiation. Derivative of tan of xy, that's going to require the chain rule and a product rule. So for the outer function, we have tan of something. Derivative of that would be secant squared of the same something, so of xy. Now we have to multiply by the derivative of xy, which is going to require the product rule. So let's bust out the box and ribbon here. I've got factors of x and y, whose derivatives are 1 and dy over dx. Using the ribbon to multiply that out, inside of parentheses now we have y plus x dy over dx, and all that's going to equal the derivative of x, which is just 1. To get dy over dx by itself, let's divide by secant squared of xy. And dividing by that actually means multiplying by its reciprocal, so we actually end up with a cosine squared xy on the other side, which is kind of nice. And then, let's see, we can subtract a y from both sides, divide by x, and that ends up matching answer choice E. On this problem, they want the derivative of this equation. Since y is going to be tough to isolate, we're going to use implicit differentiation. So going from left to right here, derivative of y squared, that's going to be 2y times dy dx, dy over dx. That's our chain rule in action. For this next one, we're going to need the product rule for this thing. So I've got my box and ribbon here, and my two factors. We have negative 2x squared for the first one, and y is the other factor. So derivative of negative 2x squared, that's going to be negative 4x. Derivative of y is dy over dx. Using the ribbon now to put it all together, we've got negative 4xy for that first term, minus 2x squared dy over dx for the next term. And then that's going to equal the derivative of 8, which is 0. Okay, let's just keep the dy over dx stuff on the left side, and let's move this 4xy over to the right side. So we have 2y dy over dx. We have the negative 2x squared dy over dx on the left side. On the right side, we have positive 4xy if we add that over there. Now that I have only dy over dx terms on the left, I can factor out dy over dx, leaving me with 2y minus 2x squared in the parentheses. And then I can go ahead and divide by 2y minus 2x squared. So there's what our dy over dx looks like, only that doesn't match any of the answer choices. So we can actually reduce this a little bit by 2's. That's going to be 2xy over y minus x squared, and that is going to match answer choice B. For this problem, we're given this equation, and we want the derivative of this thing at x equals pi over 2 and y equals 1. So let's go ahead and use implicit differentiation, because it's going to be kind of hard to isolate y otherwise. So going from left to right, this is going to require a chain rule on the left side here. I've got cosine of something. Derivative of that would be negative sine of something, so negative sine of xy. Now I have to multiply by the derivative of xy, which itself is going to require a product rule. So let's use the box and ribbon here. My two factors are x and y, and the derivatives of those are 1, and since we're using imp diff, this is going to be dy over dx. Using the ribbon to multiply that out, and now all this is going to end up in parentheses, we've got y plus x dy over dx. So that's going to equal, on the right side, we have the derivative of y, which is dy over dx, and the derivative of negative 1 is just 0, so we don't have to write it. All right, so we're going to have to distribute this negative sign of xy in order to have a hope of getting dy over dx isolated. So this is going to be negative sine, or negative y sine xy minus x sine xy. All of that is equaling dy. And now let me get everything over to the left side. I like getting things on the left side because that tends to be how you match one of these answer choices. So I'm going to have a negative, let's see, negative x sine xy dy over dx. And I also have a minus dy over dx if I subtract this over to the left side. And that's going to equal a positive y sine of xy if I add this over to the right side. All right, now I can factor out a dy over dx. That leaves me with negative x sine of xy minus 1 in a parentheses. And now I can go ahead and divide by all that, giving me this stuff over here on the right side. At this point now I have to plug in pi over 2 for x and 1 for y. So let's evaluate this derivative at pi over 2 comma 1. So let's see here. In our numerator, we've got the y value 1 times the sine of the x value pi over 2 times the y value 1. So that's all in the numerator. Denominator, I have negative, let's see, x value is pi over 2. We had sine of same stuff we have up here, pi over 2 times 1. And we also have a minus 1 there. Back in the numerator, this is sine of pi over 2. That's 1 times the 1 here gives us a grand total of 1 in the numerator. In the denominator, we saw that all this sine stuff came out to 1, so we really just have negative pi over 2 minus 1 down there. And that does not match any of the answer choices. Of course, they don't leave a fraction in a fraction for answer choices. So let me combine the stuff in the denominator now. I could get a common denominator of 2. This is really negative pi over 2 minus 2 over 2. I can merge that into one big fraction of negative pi minus 2 all over 2, and that's still all in the denominator. Same change flip. Multiply by the reciprocal, I now have 2 over negative pi minus 2. And that still doesn't quite match any of the answer choices, so I'm just going to multiply the top and the bottom by negative 1, and that makes this negative 2 over pi plus 2. That finally matches an answer choice, sort of. Choice B. On this problem, they want to know the slope of the line tangent to this crazy-looking graph at the point 2 comma 1. So to get this, we first need to take the derivative of this thing, and it's going to require implicit differentiation because y is kind of all over the place. And then we're going to have to plug 2 comma 1 into that. All right, so taking our derivative, we've got the derivative of x squared, which is 2x. Derivative of xy requires a product rule. So breaking out the box and ribbon here, we've got factors of x and y, and their derivatives, which are 1. And since this is imp diff, dy over dx, multiplying that out, we've got y plus x times dy over dx. All of that is going to, let's see, we're adding y squared's derivative, so that's going to be 2y dy over dx there. And that's going to equal the derivative of 7, which is 0. All right, let's put the stuff with dy over dx, or keep it on the left side, move everything else over to the right side. So on the left side, I've got x dy over dx, 2y dy over dx. And moving stuff to the left side now, I'm going to have this stuff equaling negative 2x minus y. Now I can factor out a dy over dx on the left side, leaving me with x plus 2y. Dividing by x plus 2y, I have negative 2x minus y over x plus 2y on the right side. And at this point, it's time to plug in 2 comma 1. So evaluating this derivative at 2 comma 1, we have in the numerator negative 2 times the x value 2 minus the y value 1. All that over the x value 2 plus 2 times that y value of 1. In our numerator, we have, let's see, negative 5 when the dust settles there. Denominator, we've got 2 plus 2, which is 4. So negative 5/4, which is going to match answer choice B.